66 million years ago, Earth experienced its fifth mass extinction. 3/4 of all species were wiped out, and in their place lay an enormous void, waiting to be filled. For the next 40 million years, there was no telling who or what would fill it. 1-ton snakes in the swamps, 18-meter whales in the seas, an Antarctica covered in forest, and crocodilians that ran on land. But first, let us return to that final morning. It was another morning. The sun rose slowly above the forests, and across the planet, life began as it always had. Duck-billed Edmontosaurus traveled in herds. Giant Alamosaurus stretched their long necks towards the highest leaves for their first meal of the day. Pterosaurs glided overhead, and in a darker corner of the forest, a predator silently tracked its next meal. Up to that moment, everything was normal, except for a bright object in the sky, growing larger by the hour. At first glance, it would have been almost indistinguishable from a star, but unlike the other stars, it was drawing closer to Earth, swelling with every passing moment. An asteroid 10 kilometers across, roughly the length of 100 football pitches, and by then, nothing could stop it. It drew closer. It entered the atmosphere, and it struck what is now Mexico's Yucatan Peninsula with terrifying force. In an instant, the sky blazed with a light bright enough to rival the sun. The energy of the impact shattered the Earth's crust. Rock vaporized. Billions of tons of material were hurled into the sky, and on the surface of the Earth, the vast Chicxulub crater formed, roughly 180 kilometers across, but the crater was only the beginning. Seismic waves from the impact tore through the planet. They triggered earthquakes of around magnitude 11 and tsunamis more than a kilometer high. The force of the impact drove the dinosaurs' own legs up into their bodies like arrows. Many died in those first seconds, without ever knowing what had happened. Such was the violence of the collision. And as if that were not enough, in the first hours after the impact, some of the rock hurled skywards traveled beyond the atmosphere. Then it fell back to Earth. As the fragments re-entered the atmosphere, they became incandescent fireballs, raining down across the planet. And many animals living far from the impact site died in that wave of fire. First, the sky turned white, and then pitch black. Dust, soot, and sulfur filled the atmosphere and shut out the sun. The world endured 2 disasters in succession. First, hours of searing heat, then years of total darkness. Photosynthesis came to a halt within 2 weeks of the impact and did not resume for around 2 years. The fine silicate dust took 15 years to settle out of the atmosphere completely. Plants began to die. Then the animals that fed on them, and then the animals that hunted those. One by one, they vanished. The world that had awakened that morning as it always had no longer existed. In the end, roughly 3/4 of all species on Earth would be erased. The great age of the dinosaurs was over, but some animals survived the catastrophe. And when we look at what those survivors had in common, a pattern emerges. They were small, they could shelter underground or in water, and they did not depend on a single source of food. Every animal you will meet in this video descends from creatures that possessed those 4 advantages, and this is where the story truly becomes interesting. So, as most of life on Earth was being wiped away, who survived? And more importantly, Who inherited the world the dinosaurs left behind? Our story does not begin where the asteroid struck. It begins with what came after. The first few million years after the catastrophe were among the strangest in Earth's history. Most of the old ecosystem had vanished, leaving enormous ecological gaps behind. Every animal that survived had to carve out a place for itself in this new world. Meanwhile, the land itself was taking on a strange color. The first two inhabitants of this stripped bare world were fungi and ferns. First came an explosion of fungal spores. A dead forest, after all, was an endless source of food for anything that fed on decay. Then came the ferns. Among the hardiest plants of all, they could persist where there was almost no light. Their spores spread across the land. Hell Creek in North America had been one of the dinosaurs' final strongholds, and even after the asteroid struck, life here did not disappear completely. Animals such as Borealosuchus and Champsosaurus managed to survive the catastrophe. Borealosuchus was a true crocodilian. Champsosaurus merely resembled one. It had a long snout and a crocodile-like body, but belonged to an entirely different lineage, the Choristoderes. Two separate lineages, the same refuge, the same survival strategy. One of the main reasons was that both were closely tied to water, shelter beneath the surface, combined with a flexible metabolism, gave them an enormous advantage during the long famine. As the world outside collapsed, they crossed from the old world into the new, living envoys, carried from one age into the next. But they were not the only survivors. So, what happened at Ground Zero itself? For years it was assumed to have been a sterile dead zone, but in drill cores recovered from inside the crater, scientists found traces of life in sediments deposited immediately after the impact. Burrows, tunnels, cavities. Within just a few years of the impact, the crater had become habitable again. The deadliest place on Earth had rebuilt its own ecosystem in only a few years. And then there were the ammonites, baculites, hoploscophites. For a long time, scientists believed that every ammonite had died the moment the asteroid struck. But the reality was more complicated. Some ammonites survived for around 500,000 years after the catastrophe. We know this from the fossil record at Stevens Klint in Denmark. The last representatives of the Old World had clung on through the first 500,000 years of the new one. But eventually, their lineage came to an end as well. Meanwhile, the Earth had begun to change once more. The sunlight returned. Then came the first conifer forests, rising towards the sky. The Dark Age was ending, and from its own ashes, the world was giving rise to a new ecosystem, because the rulers of the old world were gone. So, who was first to fill that empty space? The clearest answer lies in Colorado, among a series of bluffs known as Corral Bluffs. What makes this site extraordinary is that the first 1,000,000 years after the catastrophe are preserved here without a single gap. The layers can be read like the pages of a notebook. On the earliest pages, we find mouse-sized mammals among the survivors. 100,000 years later, the largest had reached the size of a raccoon. Among them was Loxolophus, an omnivore that foraged for food in palm forests. 300,000 years later, The largest mammals were the size of beavers. 700,000 years later, some weighed more than 50 kilograms. One of them was Ectoconus, a herbivore unlike any animal alive today. Then there was Eoconodon. It was the size of a wolf, and the team that discovered it nicknamed it the wolf pig. So, in the first million years after the asteroid struck, mammals were thriving. Their body mass had increased 100-fold. But how was that possible? Part of the answer is exactly what you might expect. The predators that hunted them and the animals that competed with them were gone. But the other part is something you would never guess. In those same rocks, scientists discovered fossilized seed pods dating to 65.35 million years ago. The oldest known legumes, the ancestors of beans, peas, and lentils. For the first time, a protein-rich family of plants had appeared, and the mammals grew. The extinction of the dinosaurs did not simply make room for mammals. At the same time, an entirely new source of food had emerged. But that was the story in the north. At the equator, something far stranger was happening. The Cerrejón swamps. In what is now Colombia, lay the swamps of Cerrejón. The heat was intense, and the air was heavy with humidity. The vegetation was dense and dark. The vast ecological void left by the dinosaurs was rapidly being filled, and during the Palaeocene, it was reptiles that filled it. As the climate grew hotter, cold-blooded animals began to push the limits of body size, and one of them was Titanoboa carrejoniensis. Imagine a modern anaconda scaled up. But even that fails to do it justice. 13 meters long, more than a ton in weight, a colossal mass of muscle, roughly as long as a school bus. It was an enormous predator, moving silently through the murky water, hiding beneath the surface, using the clouded swamp to close in on its prey, and unleashing all that muscular power at precisely the right moment. The intensely hot, humid climate of the time created the ideal conditions for a cold-blooded reptile such as Titanoboa to reach such an enormous size. At least, that was the original explanation. When Titanoboa was described in 2009, researchers used it almost like a thermometer. For a snake of that size to survive, they argued, the average annual temperature would have needed to be between 30 and 34 degrees Celsius. But objections followed almost immediately. Snakes can regulate their body temperature to some extent through their behavior. And when the same method was applied to other giant reptiles, it produced inconsistent results. There was another possible explanation. Perhaps the heat allowed Titanoboa to become so large. Or perhaps the real reason was that no large mammalian predator yet existed to compete with it. The void was vast, and whatever filled it was likely to be vast as well. And so, Titanoboa became the largest known snake in history. But this swamp was not the kingdom of a single monster. Puentemis shared the same waters, a giant side-necked turtle, around 1.5 meters long and weighing tens of kilograms. Its thick shell made it one of the most difficult animals in the swamp to kill. But even armor offered little protection against the animal I am about to show you, Anthracosuchus balrugus. It was named after the Balrog from The Lord of the Rings, because it, too, was brought up from the depths of a mine, a crocodilian relative around 5 meters long, perhaps weighing more than 400 kilograms, with short and immensely powerful jaws. jaws capable of crushing a turtle shell, 1/2 meter across. Surviving here required more than size alone. Your defenses had to be stronger than your rival's attack. And there was another inhabitant of the swamp, Acherontissuchus, around 6 meters long. It was a fish hunter with a long, narrow snout. It was not as heavy as Titanoboa, but it could pose a serious threat to young Titanoboa. That is why the swamps of Cerrejón had no undisputed ruler. Titanoboa was a hunter, but its young could become prey. Pointemis was armored, but some jaws could break that armor. This was an ecosystem in which giants tested one another. The dinosaurs were gone, but the age of giant reptiles was far from over. 10 million years after the catastrophe, around 56 million years ago, the Earth faced another upheaval. In what amounted to an instant on the geological timescale, an enormous quantity of carbon was released into the atmosphere. Global temperatures rose by between 5 and 8 degrees Celsius. The oceans acidified. A wave of extinctions swept through the deep sea. This event is known as the Palaeocene-Eocene thermal maximum. And when you hear where its clearest record was found, it should send a chill down your spine. Inside the Chicxulub crater itself. Cores drilled from the floor of the crater preserve the signature of that warming, average sea surface temperatures above 37 degrees Celsius, and bottom waters starved of oxygen. Within the scar of one catastrophe lay the record of another, 10 million years later. And on land, as the world warmed, the modern orders of mammals appeared across the northern hemisphere with remarkable suddenness. The first primates, the first odd-toed ungulates, the ancestors of today's horses and rhinoceroses, and the first even-toed ungulates. That last group matters, because from within the even-toed ungulates, a lineage was about to emerge that no one could have predicted. A lineage that would abandon the land entirely. Let us follow it. As time passed, the Earth grew hotter still. In the early Eocene, the global average temperature rose above 25 degrees Celsius, a planet roughly 10 degrees warmer than it is today. There was no ice at the poles. The Earth had become a greenhouse world in the truest sense. Sea levels stood some 60 to 100 meters higher than they do today. Most of the planet was hot and humid. And in the seas of this hot world, one of the most important transformations in evolutionary history was underway. Mammals were returning to the water. One of the earliest representatives of that transition was Pakicetus. It walked on 4 legs. It lived at the water's edge, feeding on fish and small vertebrates. It was not yet a giant whale of the open ocean, but this is where the journey began. So how do we know that this wolf-sized land animal belonged to the whale lineage? Because of 2 bones. The first is a thickened fold of bone in the ear region, known as the involucrum. Among mammals, this structure is unique to whales, and Pakicetus had it. The second is an ankle bone with a distinctive double pulley shape. That form occurs in only one group, the even-toed ungulates. Deer, cattle, pigs. Together, these 2 bones point to a remarkable relationship. Whales belong within the even-toed ungulates, and their closest living relatives are hippopotamuses. Then came Ambulocetus, around 3 meters long. It could walk on land and swim in water, a walking whale caught between two worlds. And then Pakicetus. Its name means good mother whale, and that name is no accident. It spent most of its time at sea, but its ties to the land had not yet been severed completely. How do we know? A calf was found inside the body of the fossil, and its head was pointing towards the birth canal. That matters. Land mammals are generally born head first. Whales, however, are born tail first. Otherwise, the calf would be unable to reach the surface to breathe while its body was still inside its mother. It would drown. This suggests that Pakicetus may still have given birth on land, but we have only one specimen, and we know that bones can shift during fossilization. So this interpretation is not conclusive. It remains a matter of debate. Together, these three animals reveal an extraordinary transformation. A mammal that once walked on land gradually takes to the water, and as it does, both its body and its entire way of life begin to change. Millions of years later, the seas began to fill with a new kind of mammalian predator. One of the most remarkable was Basilosaurus isis, an enormous archaic whale reaching between 15 and 18 meters in length. Its name means king lizard, but it was not a lizard. It was a whale. With its long body, it moved through the warm Eocene seas, hunting with sharp teeth, and among its prey were young Daeodon atrox. This is not speculation. Bones belonging to juvenile Daeodon have been found in the stomach region of a Basilosaurus. Basilosaurus was an ambush predator, seizing its prey and tearing it apart. Mammals were no longer merely small animals clinging to survival. Some had begun to rise towards the very top of the marine food chain. But Basilosaurus was not the only danger in Eocene waters. Another giant reptile was moving through those warm seas. Palaeocene colosseus, an immense sea snake reaching between 8 and 12 meters in length and weighing around a ton. Sharks, too, were growing larger during this period. Some reached between 8 and 10 meters in length. At that size, they were no longer ordinary hunters chasing small fish. Marine mammals were on the menu as well. And millions of years later, along that same evolutionary path, the story of one of the greatest predators the ocean has ever known would begin. Megalodon. I have explored Megalodon in detail before. Drawing on new research published in 2025, you can find that documentary through the card above. But for now, let us return to the Eocene, because after the extinction of the dinosaurs, whales were not the only animals filling the space that had opened up in the sea. Sharks were growing too, taking their place among the ocean's most powerful hunters. But perhaps the most surprising landscape of the Eocene world lay at the southernmost edge of the planet, in Antarctica. Today, it is a vast white continent buried beneath the ice. Back then, Antarctica was covered, not in ice, but in forest. But these were not the forests you might expect. The dominant tree was the southern beech, Nothofagus. Alongside it grew podocarp conifers and ferns. 6 months of darkness, 6 months of daylight. How could that possibly work? These forests had adapted to the polar cycle. More remarkable still, giant penguins lived along the coast, Palaeodiptes gunnari and Anthropornis nordenskjoldi, which could grow as tall as a human. Today we picture penguins against a backdrop of glaciers. but millions of years ago. Some walked along coastlines where forest met the sea. Looking at Antarctica today, that world is almost impossible to imagine. But as the Earth's climate shifted, the face of an entire continent could be transformed, and this warm age would not last forever. Let us pause here for a moment. There is something important we need to recognize. The space left behind by the dinosaurs was filled by giant reptiles, birds, and crocodilians that took to the land. Mammals were not the first to inherit the world. So, how did they ultimately come to dominate the planet? That is the next part of our story. We have seen that mammals were steadily growing larger and becoming more diverse, but they were not yet powerful enough to claim the world unchallenged. The heirs of the old world remained formidable. Above all, the crocodilians. When we picture a crocodile today, we imagine a predator lying in wait at the water's edge. But in the Eocene, these crocodilian relatives were something else entirely. One of them was Basilosaurus. It had hoof-like feet and upright legs. Its body was built for life on land, and in the forests of Patagonia, Cerrejón was on the prowl, an armored predator, fully adapted to life on land. And mammals were among its prey. Some of those rivals were the direct heirs of the dinosaurs themselves, the birds. But first, we have to ask, how did birds survive the catastrophe? Not all of them did. When the forests collapsed, almost every lineage of tree-dwelling bird was wiped out. Most of the survivors lived on the ground, had beaks, and could feed on seeds, because a seed can wait, even in the absence of light. Every bird you see in the sky today descends from those few surviving lineages. Some birds lost the ability to fly, and in return, they became lethal hunters on the ground. Terror birds, Eleutheronis, Palaeocene. But terror birds would not reach their peak until much later. Calencan lived in Argentina 15 million years ago. With a skull 71 centimeters long, it holds the record for the largest skull of any known bird. It stood 3 meters tall and weighed more than 100 kilograms. It could wield its enormous beak like an axe, with enough force to shatter a prey animal's spine in a single blow. Most of the dinosaurs were gone, but in some parts of the world, birds, their direct descendants, had once again become giant predators on land. Where great carnivorous dinosaurs had once run, giant birds now took their place. Meanwhile, mammals were diversifying rapidly, producing forms unlike anything familiar to us today. One of them was Uintatherium, a giant herbivore weighing around 2 tons. It had bony protrusions on its head and large, blade-like teeth in its mouth, a remarkable sight for a plant eater. Elsewhere in Asia lived Andrewsarchus, an animal weighing around 1 ton, with an enormous skull 83 centimeters long. The only known specimen was found in the Gobi Desert of Inner Mongolia. Mammals were no longer merely the small, hidden creatures of the post-asteroid world. Some were growing larger, some were arming themselves, and others were developing body plans unlike anything that had come before. But this warm age would not last either. The Earth was changing once again. Around 34 million years ago, global temperatures began to fall. Antarctica was freezing over, and life stood on the threshold of another transformation. This period is marked by the great upheaval known as the Grande Coupure. The Great Break, global cooling, combined with the spread of species from Asia into Europe, overturned the old balance. Once again, some animals disappeared, others spread, and new giants emerged. Among them was one of the largest mammals ever to walk the Earth, Paraceratherium, weighing around 15 tons, standing roughly 5 meters at the shoulder, a giant, hornless relative of the rhinoceros. It was the size of a 2-story building and had evolved to reach vegetation on the highest branches. The dinosaurs had been gone for millions of years, but on land, the evolutionary race towards gigantism was still underway. By the Oligocene, predators had evolved strikingly different ways of hunting. One of the most remarkable examples was Daeodon. It stood around 2 meters at the shoulder, with a skull nearly a meter long. It could scavenge from carcasses, but would also pursue live prey when the opportunity arose. Its jaws were powerful enough to crack bone. In short, Daeodon's greatest advantage was brute force. During the same period, on another continent, lived a very different kind of hunter, a nimravid called Dinailurictis. Nimravids bore a striking resemblance to cats, but belonged to an entirely separate family. Weighing around 130 kilograms, this saber-toothed hunter relied less on strength than on ambush and timing. It closed in on its prey, then struck at the neck. But these two magnificent predators never met. Daeodon lived in North America, while the nimravids lived in Europe. And yet, during the same period, on 2 separate continents, 2 very different solutions to the same problem were evolving. One relied on force, the other on timing and precision. Yes, that asteroid brought the world of the dinosaurs to an end. Vast ecological spaces were left empty. The animals that survived spread into them. Reptiles grew to enormous sizes. Mammals diversified. Some returned to the sea. Some reached immense sizes on land. Some became predators. Others continued to live in the trees. And millions of years later, the extinction of the dinosaurs proved to be a beginning for other species. That is why what happened 66 million years ago is not simply the story of how the dinosaurs died. The real story is what happened to the Earth after they were gone. Because when the asteroid struck, one world ended, but life did not. In the darkness, fungi flourished. Beneath the water, crocodilian relatives waited. The last ammonites held on for another 500,000 years. Then, the forests returned. Titanoboa emerged in the swamps. Basilosaurus hunted in the seas. Forests spread across Antarctica. Crocodilians ran on land. Terror birds hunted. And Paraceratherium reached the highest branches of the trees. But this entire story can be reduced to a single sentence. The asteroid did not create mammals. It simply removed what stood in their way. And among the small mammals that survived in that darkness, by sheltering underground and waiting, there was one in particular, Purgatorius, a squirrel-like animal, weighing only a few hundred grams, and living in the trees, one of the earliest primate-like creatures known to science. That morning, There was no special reason for this little animal to survive. It was simply small, it could hide, and it ate whatever it could find. And 10 million years later, when the planet warmed rapidly once again, its descendants gave rise to the first primates. Today, we are living through rapid warming once more. But this time, the cause is not a rock from space. Yes, the age of the dinosaurs was over, but the story of the Earth was only just beginning. And we are part of that story. Thank you for watching. See you in the next video. Stay curious.